What's going on?
So, just a quick reminder what you guys did on Friday. In your last lesson, remember that an arithmetic series is the sum of terms in a sequence where each term is obtained by adding your common difference. So what we're going to be talking about today and next time are geometric series. And we talked in our very first introductory lesson, our geometric sequences are obtained by multiplying that common ratio to the preceding term. What we're focusing on today are what we call finite geometric series, meaning there's a set or finite number of terms, meaning 5 terms or 20 terms or whatever it is. What we're going to talk about on Thursday are what we call infinite geometric series. It has a little bit of a calculus kind of nuance in it. It's kind of hard to think about until we really get into it. So just know for now that we're looking at series that have a certain number of terms that we're summing, okay? Our formula to find the sum of a finite geometric series is given by taking our first term times the quantity 1 minus r to the n over 1 minus r. So we know that a sub 1 indicates our first term in the series. We know that r is our common ratio. And then n is the number of terms in our series. Okay. All right, so we are going to start with an example dealing with money. It says a person deposits $2,000 every year into an IRA, which is kind of like a savings account, that pays 6% interest per year, compounded annually. So the first part of this, we are going to develop the series for this situation after n deposits. Basically, we're writing the general series here. So let's think about this. Let's say B for balance. Our initial balance, or B sub 1, is that initial deposit of $2,000. This is before any interest has been accrued. It's right when you put that money in your bank. B sub 2, what all goes into our balance now a year after we make that first deposit? What? That's 6%. So we are taking that initial deposit of $2,000 times 1.06, which would allow us to add that 6% on top. What else goes into that balance? Another $2,000. So we have our new deposit plus the deposit we made a year ago with the interest. All right, let's think about the year after that. what goes into our balance now? Connor? Okay, we're gonna not actually like calculate it out at this point. We're just writing the terms. So let's think about this. We are depositing another $2,000, right? We're told we're doing that every year. We're adding to that $2,000 the $2,000 from the previous year. Now that has accumulated or accrued interest one time, right? How many times now has this amount accrued interest down here? If it's been in there 2 years now, twice. So now this is 2,000 times 1.6 squared. Okay, let's look at one more balance, kind of get through the pattern here. So the next year we're adding another $2,000. This amount now has earned interest how many times? Twice. So now that becomes 2,000 times 1.06 squared. And how many times has this amount accrued interest now? 3 times. Okay. Now my goal, and I'm kind of running out of room here, my goal is to write that general series B sub n. So here's what I want you to notice. Notice this value of n compared to this exponent and how that kind of mirrors this general geometric series up here. That value of n compared to that exponent here. Okay? Yeah? So what we're going to say is we have our basically initial amount, that 2,000. I'm missing a term in that B sub 4, aren't I? Yeah, I am. I just realized that. There should be another 2,000 times 1.06 to the first in there. And then plus the 2,000 times 1.06 to the first, plus 2,000 times 1.06 squared. I don't care that you have a ton of terms in the middle, but what you need at the end for this general series is no matter what your value of n is here, the last exponent is what? 1 less. So in general, 2,000 times 1.06 to the n minus 1. Okay. So now using that series, we can answer the next couple of questions, which is actually looking at kind of our total balance. How much is in the IRA in 3 years right after a deposit is made? So let's focus on that first. So from when we started, B sub 1, 3 years from then would be this series, right? Right after that deposit. Okay? So what we can do for the first question that we're asked is you can take your calculators and literally just add the 2,000 plus 2,000 times 1.06 plus 2,000 times 1.06 squared plus 2,000 times 1.06 to the third. 749, and since we're talking about money, 23 cents. And again, where we got that is just simply from that series that we had written for B sub 4. We just added those up. Okay. Are we going to want to do that for our balance after 50 years? Probably not. Okay. Here's where that sum formula comes in. Okay. So we're just going to substitute our values, starting with A sub 1, which is our 2,000, times the quantity 1 minus our value of R. What is our value of R here? 1.06, exactly. To the n, so in this case, not 50, what should it be? 51. Just remember that B sub 1 is when you make the first deposit, so 50 years from that would really be 51. And then all over 1 minus 1.06. Okay? And then from here, it's just a matter of evaluating that in our calculator. Just be careful. What I would suggest to you is that you do what's inside those parentheses first. So work on that numerator, divide it by the 1 minus 1.06, and then finally multiply it by that 2,000. What questions do you have? Okay. Our next example is actually going to then lead us into Thursday as well. We'll come back to this example. What's happening here is we have a patient, we're a doctor. We are given 20 milligrams of some therapeutic drug. Each day, the patient's body metabolizes 50% of the drug present, so that after 1 day, only 1/2 of the original amount remains. After 2 days, only 1/4 remains, and so on. The patient is given that 20 milligram injection every day at the same time. Okay? So in the first part, kind of similar to the last example, we are first going to write a geometric series that gives the drug level in the patient's body right after the nth dose. So let's start this in a very similar way to how we started the first example. So what do you want to call this? D for drug? So D sub 1 is what? 20. Bless you. D sub 2, so let's think about what's happening here. What happens to that initial 20 milligram injection?
Divides in half.
It divides in half. And then what else happens? 20 more. So what about the third day? We have another dose of 20. The dose from the previous day is cut in half. And then the dose from the first day is exactly cut in half again, or 1/2 squared, right? And then that continues. So then again, our final goal here, how can we write the series for the nth day or the nth dose? Take just a second with your table, kind of come up with that. So a couple of things that I'm seeing to watch out for. Make sure you show the first term, which is in this case 20. Put a couple more terms in there, so definitely to the first. If you want to include one more, that's fine, to the second. Basically what you're doing is showing the pattern there. And then I'm seeing a lot of you then just jump right to the last term, which is the 20 times 1/2 to the n minus 1. But what you really need to show is that there are terms in the middle, okay? So you have to indicate that there are terms in the middle. Otherwise, you're saying that those are the only terms, right? Okay. So then the second part, what quantity of the drug remains in the patient's body after the 10th injection? So you have options here. Morgan probably wants to write out all 10 terms and add them up because that's what she does. But we have these beautiful sum formulas that kind of cut out that tedious work, right? Okay. So I'm looking for now D sub 10. And then we can use that sum formula to find what we're looking for. So initial value is 20. Our common ratio here is 1/2. And then again, just really be careful with your calculator. If you're not getting 39.96, please let me know and I can kind of look at what you're putting on your calculator to help you out. All right, last little bit here, looking at geometric series and our sigma notation. So like I mentioned in your warm-up, you are going to have both arithmetic and geometric kind of thrown together. So it's up to you guys to make that decision on whether a sequence or series is arithmetic or geometric. So always keep that in the back of your mind. Okay, since we are talking about geometric series, let's start off by finding our common ratio. The easiest way to find that common ratio is just to take literally the ratio of like term 2 over term 1. So 16 over 64 is 1/4, right? Okay, so that's our value of R. When we are writing sigma notation, so kind of like what we went over at the beginning of class, this is going to be very, very much the same. But instead of using that formula for an arithmetic sequence, we need to use the formula for a geometric sequence. Okay, that a sub 1 times r to the n minus 1. Our first term is 64. That common ratio 1/4. That then is what goes in front of our sigma. And then again, we just have to figure out how many terms really. Because we're starting with our value of n being 1. And then how many terms do we have here? Oops. She said it. I heard you say it too. Okay? So that's what we're looking for. All right, last example. Find the sum of the series. Make sure that you really look at that formula that's in front of sigma. That should stick out to you as being geometric. So that's going to clue you in to your geometric sum formula. In this case, we're finding S sub 10. And how did I know that? The number on top. Yep, exactly right. What's your first term? What's your first term? 4. What's your common ratio? 2. Okay, go ahead and take a minute to finish that.
Why is the first value 4? I don't know.
What?
If you look at the,
Ask me that question again.
why is the first value 4?
It's not.
1?
No, it should be 8. So if we take that first value of n, substitute it in, that gives you the first term. A lot of times that is n minus 1, which is why I immediately said 4 there, because a lot of times it gives you that value, but it's not. I should have paid attention. So it's 8, yes.
So would our n for the for this part right here be 11?
Okay, we should be getting 81, 84. Yes? Okay.